Okay, now remember the video before this, we talked about the pre-image, and the pre-image is the first image. And the image is the final one. So I'm going to put first and final. And this, I'm giving the points here so that we get used to finding the points so that when we get ready to move, we understand what's going on. So you see your x value is 1, your y value is 1, your next x2 is what this is. It is going to be 2, and y2 is going to be 3. And I mentioned that if you try to do the slope intercept form with y2 minus y1, you're not going to get the slope that you use to do that. But anyway, if you see an equation like this, x plus 2 and y plus minus 1, don't let it scare you. It just means that all the x values, all x's, because you can only move right or left okay, all x values have to go positive or negative. So if you're going on the right side, you were going positive, right? So it's positive. And if you're on the left side, you're going negative. So if this said x minus 2, you would know that this point has to go over 2. So this is 1, and this is your first value for x, which is 1. So this would have to go over 1, 0, and 1, which would give you negative 1 because it's moving. But it doesn't say that. It says it's positive 2. So let's look at what it's going to do when it's positive 2. And by the way, this y means that all of these values, since you can only go up positive y, or you go negative y, because they only go up, you're going to go, this means you're going 1 down. Not 1 over, but 1 down. So that means that this value is going to drop down to here, because that's the y value. So let's see that on the next page, next slide, I'm sorry. So in the next slide, here this is what you do. Because it's positive over 2, you're going from 1 to 2 to 3. And then you're going to go down 1, which means that your new x value is going to be here. Which is going to be 3, 0. Okay. You had the 2 and the 3 from the other value, 2 and 3 here. So when you went over 2, 1, 2, you went down 1. Okay. You had now 3 and 2. So I'm going to write this on the other page and on the other slide so you can see the new values. But do you see they're kind of overlapping, but it's still a translation because they moved. And a lot of times people will say, well, did it reflect? Well, it's kind of a translation because it's going into itself and it's not really a reflection. Okay, so let's write down the new values. Now, here are rules for translations when we're turning 90-degree either way. You're going to turn this around, put make y negative, because normally we write like this, x and y, and you're going to turn around and you're going to make this y negative, and you're going to put it here, and you're going to put the x here. And this is just how it's written. It is backwards, it is crazy, but accept it. And so that's if it's 90 degrees. Now, if it goes 90 degrees to the right, it can still go 90 degrees to the left. And we'll get into, if y was already negative, how that works. But right now, accept this. Now, both of them at 180, both become negative. And if you think about it, if they were up top, beyond the x-axis, for them to turn around 180, they've got to kind of both have negative points. And I'm just using the triangle. Okay, so think about what this is. 270 means that you have a circle that is 360. So you're going to do 90, 180, plus another 90 is going to give you 270. So if you do 270, wouldn't it make sense that one of your x values would be on the negative side? So you're going to switch around, but this time x is going to be negative. So you look at what's going on, and it's really, you know, this angle here is going to come here, and that's how you do it. So this is 90 degrees. This is 180 degrees, and this one here for me is the hardest, the right ones, because there's no real way for your mind to think about how they work. And this is 270. Okay, let's move on. Okay, so which one is your pre-image? Well, this is your pre-image because this was the original we used before. So this is 1, 1, and this and that. And this is what I'm saying about the 90-degree rotations. They don't really look like they're going in the direction that they are. Like, this doesn't look 90 degrees, but if you were to take a paper, or you were to take a protractor and you were to look at what happened with this value and this -1 here, space, it's going like this. And then it's staying here, and that is 90 degrees. But it's 90 degrees going down. Why? Because you switch the x, and you switch the y, and you put the y here. You make the y the x value. And people get confused with that because they forget that with translations, this is how this works. So if you think about that's going 90. Now let's look over here at your 2 and your 3. Well, the next value is -3 and 2. Okay, so if we go down and we go over, go down a little bit and over, that's 90 degrees. See, that's where you see your 90s, when they come down and when they start doing the switch. Other than that, you don't really see them. And then this 5 and 0, this was your original up here was 5 and 0. So now it's 0 and 5. But look, 90 degrees. Right? See? Because that's a right angle. So that's how you get to a 90-degree translation and a rotational. You have to really look at what's going on in the situation, because like when you look at it, you go, how'd that go 90 degrees? And you say, well, it just did because we switched around the points. And for those of you who were with me yesterday, you remember I said there is a trick, and it gets really, really hard. And yet at the same time, it's kind of easy. It's not hard to do when you think about it. Okay, so here again is our pre-image. And you check the values. Make sure I'm telling you the right thing. So we had 1 and 1, and we had 2 and 3, and we have 5 and 0, and here's 1 and 1. So this is our pre-image. Okay, now we're doing a 180-degree translation, and both values are negative. So you're changing the signs, and you're not switching anything around. So it's straight up negative x, negative y. So over here, this was 1, so this would be negative 1 and negative 1, and I put that here. This was 2 and 3, so this would be negative 2, negative 3, and I put both values here, and this would be negative 5 and 0. 0 is negative or negative. Now when you look at this, if you think about it, this kind of went over here. And remember, we went 90 and up to this. So try to see if you can draw and see if you can go like see if you can go, remember you went 90 and over and down, that was 90. Okay, now if you go from here, you're going 180. Isn't 180 degrees a straight line? So now you're going to go to a straight line. So you're down in here. Okay, now you were here when you went 90 degrees down. Now what are you going to do? You're going to go from here to here. That's straight. I'm sorry, this is straight. That's a straight line from there. Sorry, that's a no-brainer. 5, 0, 5, 0. That's your straight line. And that's as straight as it gets. Okay, now this point to this point is like a perpendicular diagonal straight. So that's how you look at translations. And if you look at it, it looks like one of those pyramid glasses or a dyad type of thing. And so if you think about it that way and you start drawing lines, of course you draw lines better than I do, it kind of makes sense. Okay? So we have one more to do, and your lines are coming up pretty straight. All right, and so we have one more to do. We'll do that on the next slide. And again, this is kind of like the hourglass that I'm telling you about. Like an hourglass goes like this here. And so, but if you drew straight lines, you're kind of making like an hourglass. Because you're going here to this point, and then you're going down through this point, and then you're coming back here and going through, you're going up through this point. So if you think about it, this is a rotation that went like here, and then it did another rotation, and then it ended here. Kind of like what rockets do. So just try to think about what it should look like and what's going on when you're trying to do it, and try to do your lines a lot nicer than what mine are doing. But that's really what it's about when you're doing 180 degrees. Straight line translation. So the points change. And again, this is kind of like the hourglass that I'm telling you about. Like an hourglass goes like this here. And so, but if you drew straight lines, you're kind of making like an hourglass. Because you're going here to this point, and then you're going down through this point, and then you're coming back here and going through, you're going up through this point. So if you think about it, this is a rotation that went like here, and then it did another rotation, and then it ended here. Kind of like what rockets do. So just try to think about what it should look like and what's going on when you're trying to do it, and try to do your lines a lot nicer than what mine are doing. But that's really what it's about when you're doing 180 degrees. Straight line translation. So the points change. Okay, so when you're getting ready to do a 270-degree rotation, you change the signs and x goes to the back. So what happens is you change this one sign, and x goes to the back. So this negative value is actually going to come over here. And this negative value is actually going to come over here. And this negative value is going to come over here. And remember, 0 is neutral. So 0 doesn't change. Okay, there's no such thing in like what's the method? Sometimes if you're doing like imaginary numbers and stuff, 0, they may try to pretend it's negative for a bit, but it's not. We're just at Algebra 2 and Geometry and Algebra 1. This is a neutral number, so it's not positive or negative. Okay? And so it's neutral and it has no sign. Okay? It really is a positive number, but it has no sign. Okay? Because it's a space holder. It means we're gonna hold at 0 and then we're gonna count, or we're gonna go 1, 0, -1 and count back. So it's really considered positive, but it has no sign, so we don't change it. We just move it around. Okay. All right. So anyway, here we are. Oops. Spend too much time on these little details here. But anyway, here we are. And if you look at it, doesn't it look like it kind of moved a bit? It looks like it went too messed up. So like the other thing you could do is you could do -1 and 1, which would put it back where this, if you wanted to check yourself, you do -2 and 3, and guess what? You're putting it here, but guess what? You're not doing a full turn 180. So that's why whoever came up with this ingenious rule, they really were pretty smart. You had to turn it. Now think about it. If you were 90 degrees on this side and 180 on this side, wouldn't you be 270 on this side? Because you started over here as a circle. So you kind of started at 180, so kind of makes sense. So when you come back and draw a circle, you're at 270. That's not a complete circle. Okay, 270 is what? 3/4 of a circle. 3/4 of a circle. Because 1/4 is 90, 2/4 is 180, and 3/4 is 70. So now that you are doing this thing called trying to figure out what to do, you've got to start thinking about the concepts of how things really work. And that's the concept that you started over here. If you were here and you were doing a circle, this point is 2 and 3, and so its point is 3 and -2. You come back here and like it's 3/4 a circle, almost. You know, kind of went out. Okay, it's not a complete circle, but it's going around. That's what it's doing. So these are kind of like moving around and this and that, and you notice that this is here, the shape is here, but over, I'm sorry, when I say this is 5 and 0, and this is here, but over here it's kind of here. So, and then this point here, which is 3 and -2, was 2 and 3 up here, and it's kind of over here. It's kind of making an arc. It's making like a semicircle. So this is how you look at things too, if you can. If not, just remember the rules, and that's how we turn things around. Thanks for watching. Definitions. And then this we'll talk about in the next video. Thanks for